Hi everyone, today we'll be talking about a limit problem. And the limit problem is as the limit of x approaches 0 of 4x cotangent pi x. Before we start, there are a few things that you need to know. First, it's that, I don't know what this line is doing here. First is that the limit of sine x over x is equal to 1. Then you need to know that the limit as x approaches 0 of, for the first one, it's the limit as x approaches 0 of sine x over x is 1. Second one, limit as x approaches 0 of sine of ax over x is equal to a. And third of all, limit as x approaches 0 of sine of ax over ax is equal to 1. You should know all of this by now, as this should be given to you really early on in the unit. And if you don't know all of these, you should not be doing a problem like this yet. So make sure you know all of these. And then just something simple down here, we have 5x over y. Know that 5x over y is basically the same thing as saying 5 over y times x, which is the same thing as 5 times x over y, right? Simple. Okay. Now, let's begin. There are two ways to solve this. I'm going to talk about the first way, which is using L'Hopital's principle first, and then I'll talk about the second way, how to do it without L'Hopital's principle. So let's first prove it using L'Hopital's principle, right? Let's rewrite the problem into something that's more comprehensive. So limit, the limit, the limit as x, that's not m. The limit, okay, as x approaches 0 of 4x, okay, we can rewrite cotangent x as cosine pi x over sine x, right? Sine of pi x. So tangent is just sine over cosine. Cotangent is the inverse of that, which is just cosine over sine. Okay, this should be easy. Now let's prove it using L'Hopital's principle. So we say that the limit as x approaches 0 of the top 4x cosine pi x is equal to 0. Then we say, okay, that's a 0 over here, right? Then we say the bottom, limit as x approaches 0 of sine pi x is equal to 0. If you do not know the unit circle very, very well by now, you should not be doing these kind of problems. You need to go remember the unit circle first. So on top, it's cosine x, no, it's 4x times cosine x of pi x. You plug 0 in, so it'll be cosine of 0, which is 1 times 4 times 0, which is 0. Bottom, sine of 0 is 0. Okay, so because both of these equal to 0, we can say that, where's my dots? We can say that L'Hopital's principle applies. L-hop, that's an L, not a U. L-hop applies. So L-hop applies. And L-hop is L'Hopital's principle, right? So L-hop applies. Where's the rest? L-hop applies. Okay. So now that L-hop applies, we can say limit as x approaches 0 of the derivative of the top over derivative of the bottom. Derivative of the top, we're going to use product rule, and I've explained product rule earlier, so I'm not going to go through step by step. So it'll be 4 times cosine pi x plus 4x times negative. I should specify that, shouldn't I? So this will be minus now because cosine is negative. Cosine's derivative of cosine is negative sign. So minus times sine of pi x times pi. Chain rule. This pi is from chain rule. And this negative is because derivative of cosine x is negative sine x. Okay, so now on the bottom, it's going to be derivative of sine x. Derivative sine of pi of x is going to be pi, again, chain rule, of cosine pi x. That's pi x. Okay, now we plug 0 in. If we're plugging in 0, so on top it will be 4 times cosine of 0, which is just 4. So this is equal to 4 minus, you have the 0 here, so all of this will automatically become 0. Minus 0 over cosine of 0 is equal to 1. So 1 times pi is just pi. So your answer is going to be 4 over pi. So therefore, it's very simple, right? We just prove it's equal to 0, take the derivative of the top, take the derivative of the bottom, plug 0 in, and we get our answer. That's if you have learned L'Hopital's principle, which I explained every single step to it in my previous videos. Okay, now if you didn't learn L'Hopital's principle, here is a more complicated way to do it. So we have limit as x. The first step remains the same, right? First, we make it easier to write. We make life easier on us by separating this into 4x cosine pi x over sine pi x. Now, if we use this example that I was showing earlier, we can separate this into limit. That's not z, that's the equal sign, by the way. My pen is just lagging. So the limit of x approaches 0 of 4x over sine of pi x. Sorry, that's a pi. That's sine of pi x. Sine of pi x times the limit as x approaches 0 of cosine pi x. Cosine pi x. Okay, so what I did was I put these two, 4x and sine pi x together and cosine together. And if you don't know by now, the limit of x divided by y is equal to the limit of x divided by the limit of y. The limit of x times y is equal to the limit of x times the limit of y. So let me just write that real quick. Limit of x approaches any number, let's say 0 here, x times y is equal to the limit as x approaches 0 of x times the limit of x approaches 0 times y. I really hope you know this already, because again, you should not be doing something of this level without knowing this first. Okay, now this entire step makes sense. All right, now for the constant, so to leave the constant alone, we just put it out to make our life simple. All right, to put the 4 out here, just multiply the 4 by the entire limit to make our life easier. And if you don't know that you can do that, again, you should not be doing something of this level. So this 4 is out here now. So we have the limit of x approaches 0 of x over sine x as x approaches 0 of pi x, and over here you have the limit of x approaches 0 of cosine pi x. Now this is easy, right? This is just equal to 1. This is equal to 1, right? Cosine of 0 is 1. So because you plug 0 in, 0 times pi is 0, cosine 0 is just equal to 1. So this is equal to 1. We don't need to worry about this anymore. So now let's just prove this, all right? Sine of pi x over sine of pi x. Now isn't that very familiar? Because we just saw just now that this is equal to, we saw this formula, right? So we need to try to convert this into this formula, and we can do that by dividing everything, by putting everything under 1. So let me show you. So the limit as x approaches, so basically take the reciprocal, wait, we call the inverse. Take the inverse of this. So you have 1 over sine pi x over x. All right, really hope you know where this came from. So I just divided this over 1. So I just put let me think. Let me think how I can explain this. All right, so I took the inverse of this. Basically took this to the negative first power, right? If we take this to the negative first power, we get this. And now look at what we have here. Sine of pi x over x. Using the formula we just learned just now, this is going to be equal to whatever this value is. And in this case, it's equal to pi. So this is actually equal to 1 over pi. Okay, again, this is equal to 1. And this, let's add our 4 in the front. So this is going to be equal 4 over pi. Okay, so the key thing to understand over here is that we took the inverse of this to put a 1 over. That way, we have it in a format that we learned already. The format is sine of a of x over x. Any value a is going to be equal to a itself. And because we have 1 over on top, it's going to be 1 over a, in this case, pi. So just 1 over pi, and then we have times the coefficient we moved out in the top, which would be 4 over pi. And here we arrive at the exact same answer. And that is how you solve the limit of 4x cotangent pi x as x approaches 0. Hope this helped, and thank you for watching.